Again, let's give it a try with trial and error. It is zero product rule and factoring. I'm going to say 7x and 4x. Then I'm going to say 3 and 2. Let's take a look here. Plus, plus. You certainly get 28x squared. Then you get 21 and 8, which is 29x, and plus 6. So it works like a charm. What do you get over here? X equals. That's going to be minus 2 sevens. Or x equals, let's see, minus 3/4. All right? Look at the key. And in the key, I'm going to see those answers, at least hopefully. Minus 2 sevens and minus 3/4. All right, this section is not about using factoring with integers. This section is about using the completing the square. So looking at it, I mean, to me, it's a little more difficult, but that's what we're trying to learn. So let me just go through the steps with you. First, write down the problem. I'd say the next step, and I want to point out, let me see what they're doing over here. I see what they're doing. So what they're doing now, I'm going to get my eraser out, and I'm going to write down the missing step. And this is what you're supposed to do when you're studying a guide. All right, so I'm going to write this down. So it's going to be 28, whoops. I'm going to write the missing step down. 28x squared plus 29x equals minus 6. They want to make the a perfect square by multiplying 28 by 28. That make it a perfect square. But then they got to worry about the 29, and they multiply that by an additional 4, which would give you the 2. All right, let's put that down. So multiply both sides by 28 times 4. 4 is a perfect square, by the way. You'll get the 2 in that case. That's what we're saying about the 2. So let's take a look, see if they did that. I'm seeing that here. They multiply the first term by a 4 and a 28. Second term, when I say multiply it, they write it down. 4 times 28 times 29. And let's see, I see that over here. 4 times 20 times a 6. And then when you add to both sides to make it a perfect square, you're going to add 29 squared to both sides. All right? So what do you have now? Well, I got to do that. And I want to point out where this is coming from. You get my eraser out now. I'm done with that. And let's talk about where this is coming from. On the x squared, right? What's its coefficient? Well, looking at it, it's going to be, let's see, 2 times 28, right? That would give you 28 squared. That's why they're saying 56x, and they got to 29. Let me just briefly go through that with you. If you multiply that out, you're certainly going to get, as expected, this and this. And the middle thing would be what? It would be, I'll write it down for you. It would be, let's see, 2, whoops, sorry about that, times 56 times 29. Certainly seen the 29. And I needed that too, right? So what are you going to get? It's 28. I got a 4 then, and I see that right now. So they're working out beautifully. All right, let me erase this over here. And then what do we use? Square root rule. Oh, before I do that, I want to point out, without boring in the details, you have to do the arithmetic there. And that's 169. This over here is, again, the perfect square. You're going to use the square root rule, which says that, 56x plus 29 equals plus or minus the square root of 169, which is 13. I need to solve that for x, 56x. You would get minus 29 plus or minus 13. And then you divide through by 56, and I'm seeing this over here. So, whoops, did I say? I'm sorry, I wrote something wrong around there. 29. Sorry about that. So let's make sure we see that. Minus 29 plus or minus 13 right there over 56. I want to get my eraser out. Again, we're just talking about the key. Let me erase all this business over here. And then, what do I write down? Minus 29 plus 13 over 56. And the other one's minus 29 minus 13 over 56. And you're expected to do that arithmetic. And what would you get over there? Well, you get minus 16 over 56, and this would give you a minus, well, certainly 56 in the bottom. Let's see, 42. You have to reduce those, And, just looking simple reductions, I'm going to say 4. 4 goes into minus 16 4 times, and it goes into 56, let's see, 10, and then another 4, 14 times. And then you get minus 2 sevenths. I see that right over there. And this guy over here also reduces. If you look at it, again, looking at it, if it's just even a simple reduction, minus 21 over, let's see, that's 28, right? Then see that it's divisible by 7, minus 3 quarters as we get over there. Again, I want to emphasize over here, I felt this was really the way to go in the problem, but that shouldn't stop you from doing what Wells is doing with completing the square. All right? Thank you.